Okay, so I'm just going to pick up where I left off. As I said, anti-differentiation is the reverse of differentiation. Okay, so just to go through a few examples and show you how this works. No, I'm going to give you the rule of what you need to do. So if you think about differentiation, sorry, oh, you can't see me. Oops, sorry. If you think about differentiation, the rule is that you reduce the power by 1 and then you multiply the function by whatever the power was. So just for example, if you have y equals, let's say 3x squared, your dy dx is equal to, you bring the 2 down in front and you times it. So 2 by 3 is 6x, and you reduce the power by 1 to the power of 1, so 6x, okay? So what you do there, if you were to put it into words, is you reduce the power by 1 and you multiply the function by the power, okay? Now, for integration, what you do is you're going to, instead of reducing the power by 1, you're going to increase the power by 1. Yeah, you can take her. Yeah. You increase the power by 1. And instead of multiplying the function by that power, like here you times 3 by 2, 6, you're now going to be dividing by it. So you increase the power by 1 and you divide by the power. Okay? Now, I'm just making sure you can see that. Divide by the power. Okay, so for example, if I want to integrate, let's just say, if I want to integrate the function 3x squared, and remember that I always give it to you with a little dx beside it. What do you do? Okay, so you increase the power by 1, so it will become, let's say, the 3x, increase that power by 1 will be to the power of 3, and you're going to divide by the new power over 3. And then don't forget to put in your plus c. And I explained that at the start why. That's really important, okay? Just checking to see, can you see all that? Yeah. So what could you simplify here then? Well, if you have a look here, you have 3 over 3, which is just 1. So the integral, or if you integrate 3x squared dx, you'll get x cubed plus c. Run to get out. Okay? So in general, what you're doing there, if I put it into in general terms, the integration of a function, let's say x to the power of n dx, you're going to be doing x to the power of n plus 1, increasing the power by 1, and then dividing by that new power. And always add in your c. You lose marks if you don't add in your c. Okay? Now, I'm going to do an example of 2 of them so you can see them done, and then I'm going to set you some work, okay? So, what I might do is do the example up the top. Get rid of this for a second. I hope you've managed to take down, you don't even need this, this was just an example. Okay, so if I do example, this is from page 69, and it's question 1, and example 1 I'm going to do. It's the integral of x. So we're asking you to reverse the process of differentiation. You're trying to find the function of this. Right, what's the power of that x? 1. So if you increase that, it will become x, I'll just put that on, x squared divided by 2, add your c, and you're done. Okay? Actually, I don't need space up there. I'm going to do the next one here. I'm going to do vi. Integrate minus x squared plus 3. And they have a bracket around it, dx. Don't worry about that dx. You don't need to worry about it. Full stop. Okay, let's integrate this part. So this will be increase your power, minus x to the power of 3, and then divide by whatever the new power is. Will be like that. Okay, plus 3x. Now, if it's a constant, if you think about it, if that was a constant, if that had been something differentiated it, the answer to that, if it was x, would have been 3x. So actually what you're doing with a constant is you are increasing it by 1. So 3 will just become 3x. And you divide by your new power, which is just 1, so I don't even need to put it in there. And then don't forget, and I'm running out of space here, always put in your plus c. Okay? Now, oh, you can't see that. Hold on. Can you see that better now? The plus c. Yeah. I hope you're able to see that okay. Sorry about the state of all of this. Yeah, any questions, send them through to me on the messages on Teams, okay?